Welcome, guys. Yeah, first slide is I want to tell you something about eTemis. Just one slide. So we are an independent IT company, started in 2003 with 4 people. Now we are over 200 people with locations in Germany, France, Tunisia, and Switzerland. And our primary goal is to make software development or systems development more efficient. Of course, we do develop in projects, help our customers as software consultants, but we are also building tools, may it be as product or may it be as custom solution. And around about 80% of our staff are software developers working with customers, working on software projects, and 70% are tool developers. And this makes more than 100% because we are eating our own dog food. So we develop the tools that we use. And this is great fun. And sometimes we really have success and can shorten up things. And yeah, the Yakindo product family, some of our solutions, we decided to make them really as products. And this is labeled the Yakindo product family. And it mainly focuses embedded systems development, support you in that area. So my name is Boris Holzer. As my camera is not working for some reason, I added a photo on the slide. And I'm now for 5 years product owner of one of our Yakindo products, and it's called Yakindo Traceability. And as the name says, it's a traceability tool. Yeah, I have some background in software development, 32 years experience. But this is the first time that I do a webinar from my home office. So welcome to my living room. Today, I want to tell you what I learned during the last 5 years as product owner of a traceability tool. I had a lot of webinars, discussions, conferences, talks with customers, read a lot about it, and I just want to give you a non-objective view on that topic. So seen from a tool developer, and it's not a ad or commercial for our tool. Of course, it's the best traceability tool in the world, definitely, without any irony. But today I want to focus more the topic traceability than to focus our tool. So let's start with what is traceability. On the first slide, I always put the definition that is given in the Automotive Spice process specification because I like it a lot. I like it for 2 reasons. The first reason is that it defines what traceability is. So it's link between works products. It's about links between work products, but it does not stress the word requirements traceability. So traceability. Each work product that is in your work process, that exists in your work process is relevant, not only requirements. So it's really about traceability, but not about requirements traceability. The second point why I like this definition is because it gives a motivation. So traceability puts you in a position that you can do coverage analysis, impact analysis, or even track your project status. And I have example of what more is possible than what is given in this simple definition. Second definition is from IEEE Systems and Software Engineering vocabulary. And they say it's all about relationships between products of the development process. So I put it here because I like the word development. So I prefer to talk about development traceability, not about requirements traceability. But on the other hand, to distinguish, and the term requirement traceability is set. I have to live with it, even though I would prefer development traceability. Yeah, the last quote that I put on this slide is from a research project called SPACE, Software Platform Embedded Systems 2020. The project itself is from 2013, but it has been called 2020, so that's just the name of the project. And this is a project that our tool originated from. And The first thing I like to mention is that we distinguish between linking and tracing. So in our understanding, a trace is a chain of links. So you see this trace from A to E consists of 3 links. On the other hand, this means that each link, of course, is a trace, because a trace can have the length of 1. The second thing is, on first view, a trivial conclusion. So if you want your work products to be able to be traced, they need to be identifiable. But sometimes this is not easy. So on second view, it may be not a trivial conclusion. Here's an Excel sheet describing test cases, and I extracted it from our showcase. So test cases read from Excel, and you see the test case in cell A3 with ID 101.1 and name turnoff is in row 3. But documents are living, and we're changing data. So somebody changed the ID. So what is the identifiable in this thing? And even more things happen. So somebody changed the order within the Excel. So he changed the rows. So now our test case is in row 4. Or someone adds a column, and now you have to look in column B for the ID. And these are things that you need to be capable of when you develop a traceability tool. So you really have to think about how to recognize work products within documents. And the solution in our tool is you can reference artifacts in Excel, for instance, either by value or by reference. And if we don't find it, we start looking around. So if we have something in cell A3 and the label changed, we can give a warning. If we find it in cell B3, we can give a hint. It seems to be this guy was in column A3 before. And this is what we implemented in our tool regarding Excel. So the trivial conclusion, before you link things, you need to identify them. It's not so trivial if the ID changes or something like that.
And Boris, I mean, yeah. Excel is okay. I mean, it probably gets even worse if you go to Word or PDF.
Yeah, absolutely. Word or PDF, especially when you're extracting data based with regular expressions, you have to also take care of the surroundings. So like a version control system, you see that it does not only focus on the extracted text, but also on the context, and that's what we do. Yeah, that's a good point. That's true. So this slide stressed the ability part of the traceability word. This slide stresses the tracing part. So here we see C editor, and the links are stored in form of comments. And these comments turn into hyperlinks. So when I click on a link, the test case opens up in Excel. So this is just a GIF that I extracted from one of our educational videos. But that's traceability really literally. So we follow the trace, and we can navigate in between tools with traceability enabled. So that's really, living traceability. Then there are quite a lot of publications that stress the point traces have to be bidirectional. And I quoted the FYE Center here. So they say, bidirectional traceability needs to be implemented in both directions. From an example, from source requirement to low level requirement, and from low level requirement back to its source. And I don't agree with that. We have these discussions quite a few times when we talk with customers. And for instance, when we link requirements in doors with model elements in Enterprise Architect, and we say, yeah, we store the link, let's say, in Enterprise Architect. Yeah, but we have to store it in doors as well. Why? Because it needs to be bidirectional. No, that's not true. If we have the link, we can navigate it in both directions. Here's another definition from in my eyes, it's a traceability Bible from Gotl, Software and Systems Traceability. It's from 2012. So, and they say a trace link is an association, and it's effectively bidirectional. it can be traversed from source to target and from target to source. And that is our understanding. So I just put it on the slide because if you want to learn more about traceability, I really can recommend this book. It's quite expensive, 100 euros on Amazon. I've just checked it today. And I don't get any provision. So yeah, that's about this book. And why is traceability important? If you look at various software development specification standards or systems development specification standards, they all claim traceability to be mandatory. So ISO 26262 is about functional safety for road vehicles. They say traceability is important. The EN 50128 is about similar specification for railways. They say traceability is important, and there are quite a lot. Whenever it comes to safety critical systems or software, financial, for instance, traceability is important. And why is it so? I again quote here again the definition from Automotive Spice. It's important because it brings you in a position to do coverage analysis. You can.
So Boris, if they talk about traceability, you've shown a lot of standards talking about or saying they all stress traceability, and do they mean the same thing more or less? So if you understand traceability for one standard, is it then difficult to understand traceability for the other standard?
They are quite comparable. So traceability is in each case it's about linking between work products. But they let's say they don't have the same kind of work products.
Okay. But the concept, the abstract concept, is quite similar.
It's quite similar. And the point is, it brings you in a position to do a coverage analysis. So coverage analysis means you can find out which artifacts are linked. Is each requirement to a test case, or in other words, is it covered by a test case? And if that's the case, then we think we tested our system well. And so this coverage analysis brings you in a position to say you tested your system well. And that is why is it important for safety critical system, you should test them well. Okay, that was about traceability definitions or quotes from various definitions. Now I want to tell a little bit about how to achieve traceability. What do you have to do to link artifacts? How can you do this? I think the most popular way to create traceability is the famous traceability matrix. In this case, it's a screenshot from a spreadsheet tool, and the axis in the cells signal that this requirement number 1 is linked to the test case val1. And you see, if you are smart with your spreadsheet macros, you can really create great tools with auto folding of columns or rows and highlighting of cases where your standard is not met. This is really powerful. But there's a drawback. You see, it's only 2-dimensional, so requirements to test cases. So when we think back at the SPIS definition, this is not a traceability matrix, but a link matrix. So we want to cover the whole V, also the V model. But this is possible with spreadsheet tools too. So here's a multi-dimensional spreadsheet which links requirements so internal requirements to customer requirements to implementations to test cases. Things get big, but it covers quite a lot of you. And again, if you're smart with that, you can create a suitable tool. This can be helpful, but there's one point, and this is project complexity. We get a lot of requests from customers. They say, I want traceability. Please explain us your tool. When potential customers are not from the embedded systems field, more from let's say enterprise engineering, and they say our projects are really big, then I know that we deal with round about 1,000 artifacts that we need, or work products that we need to link. So requirements, test cases, model elements, everything counted brings us to 1,000 artifacts. When we talk about, let's say, embedded systems, and this an example for control unit in car, let's say a charger or door control unit. For simple door control unit has 100,000 artifacts roundabout in the V. So here is the V that is specified in the Automotive Spice process definition. So it says stakeholder requirements should be linked to system requirements, and system requirements to system architecture, and so on. On the right-hand side, there are the test cases and the test results. Yeah, in a let's say ECU project for a car, control unit project for a car, we deal with 100,000 artifacts. And when it comes to autonomous driving, things get really complex. Really tens of millions of artifacts in one project, in one V. And this is because of the neural networks. They need so much learning data, so much test data. This is really an explosion. So the spreadsheet approach may be suitable for these big projects, but for higher complexity, you really need a dedicated tool. Then another thing that drives complexity are heterogeneous tool chains. So you want to link from requirements tool to model tool to source code to test tool to other documents, and they all use their own tool. And most of the tools provide means to link bidirectional, but there are only a few tools which allow really traces, so a chain of links across 2 or 3 tools. This is really a challenge. And the last thing that drives complexity are different roles in your project or different domains. The project lead, he wants a high aggregated traceability status. He does not want to see all those artifacts. He just wants to say, maybe know the requirements test coverage on system level is 80%. That's a sufficient information for the project lead. The requirements responsible, he wants to know, the requirements is 80%. That means 20% are not covered. Which are the requirements that are not covered? And the software engineer, he wants maybe just to see the lower part of the V. So that's really a challenge to create a tool that, based on this data, gives views that support all these roles. I once was in a project, and the hardware testers, they refused to use another tool. They had their hardware requirements in DOORS and their test cases specified in Excel. And what they did, they opened up DOORS, they copied the ID from the requirement from DOORS and pasted it into Excel. That was their mean to establish traceability. They really refused to use another tool. And what we did in this case is to extract the information that they entered into Excel. So everybody was happy. Everybody could use his toolchain, and the project lead had the overall overview, and the requirements responsible had his overview. And even the hardware guys, which were not using our tool, but providing data for our tool, they were happy as well. So that's the thing you should really care about.
So Boris, before we go on, you right now mentioning that the team that you just mentioned was copying data from DOORS to Excel, and we have a question in the Q&A. How do you define an artifact? Because you mentioned that we're linking word products. So maybe we should also mention the granularity. So we are linking requirements, right? For example, so one requirement, we are not linking one DOORS module, we are linking one requirement. Maybe it's coming up later, but maybe you can expand a little bit on the granularity of what you need to link and trace to fulfill these standards.
Yeah, good question, and you explained it well. So granularity is really one requirement or one test case or one portion of code or one, let's say, box in your UML model or systems model. That is a granularity. So each requirement is an artifact, or each test case is an artifact. Yeah, that's a granularity that we are focusing. So when we look back at the at this traceability matrix, so each row is an artifact and each column is an artifact. So each test case in this example and each implementation detail is an artifact. Okay. So how can we achieve traceability? So this is just a rough overview of the process, and we will look at this in detail. And this process works for both for your, let's say, handmade traceability metrics and for tools. First thing is to have to collect the artifacts. So you really have to think about what is an artifact. Yeah, we once were the customers and they were using C code. And of course, they wanted traceability from software requirements to software. And we asked them, what is your granularity in the software? What do you want to trace? Is it files, or is it functions, or is it macros? What do you want to, what is really your granularity? Because in our tool, it's configurable. And they say, you mean we can configure that each function is an artifact and not the whole file? And I said, yes, that's easy. And I just demoed them, and here it works. And then they said, no, we don't want that. We are software developers. Please don't tell our process responsibles that this is possible. We want traceability only for files. That's sufficient for us. So yeah, so you really have to take care about cultures when it comes to what is an artifact. But on the other hand, there is maybe a standard that you need to comply to. And these standards define also what should be considered as an artifact. But anyhow, you need to extract the data. So how do you recognize test cases in Excel? How do you recognize requirements in Word or in another tool? That is about collecting data. And second thing, and we will see a slide on that, is the data extracted, the raw data. You need to homogenize them. Maybe it's possible you have several test tools. One is Tessie and one is let's say manual review, but each artifact is a test case. But you extract, let's say, unit tests from Tessie, and you extract the manual tests from Excel, but you need to map the data that you extracted from the tool to your data model. And once you have built your data model, you then can analyze it easily. So let's look at the details. When it comes to collect your data, really in heterogeneous tool chains, depending on the tools that you're using, that's really a challenge. And my hint is, when you want to collect data, go for the low-level interfaces. So, for instance, Yakino Traceability, we built our own parser for Rhapsody files. So Rhapsody is a modeling tool. We don't use the tool API because it's too slow. We extract the data from Polarian directly via database query. We don't use the Polarian API because it's too slow. We developed adapter to DOORS-NG, and we are using the reportable REST API from DOORS-NG, it's called. And reportable REST API suggests that it's fast, but it was slow as hell. And we opened up a case at IBM, and we had a direct developer contact to IBM, and he just gave us the connection to the underlying database. And now we're extracting the data from the database. So really go for the low-level interfaces when it comes to really hundreds of thousands of artifacts. APIs are too slow, and upcoming standards or like OSLC, which is a standard which allows, let's say, data exchange between tools. And for our cases, they are still too slow. With our partners, let's say Plato providing a system engineering tool called Eins, or ETAS providing systems engineering tools or testing tools, or Pure Variants, Pure Systems, which create a tool for variant management. We are talking really from developer to developer, and they open up the interfaces to us so that to make it possible to extract the data, these huge amounts of data, really fast. So again, message is go for the low-level interfaces when you collect your data. Second step was homogenize your data. So the first thing to homogenize is define a common vocabulary or data model, however you may call it. In the traceability field, it's called Traceability Information Model, and I've drawn one on this slide. So this requirement, Traceability Information Model says we have requirements which can be linked to test cases. We have a design elements which can be linked to requirements and which are tested by integration tests. And we have software requirements which can be linked to unit test specifications. So this is a traceability information model or data model, however you want to call it. What is not visible on the slide, requirements and test cases and all these things, of course, have attributes. So requirement has an ID and a description and a status and all and so on.
And Boris, this is something that I would have to do informally, at least anyway, because I have to define my process. What do I trace to what, and what developers are allowed to and expected to trace. So in an informal way with the Excel, I would at least have to write it down in some document. And here you're actually doing a formal notation and then being able to automate stuff, right?
Yeah, that's true. So I have a slide for that point. So if you want to analyze your traceability with a tool, you are forced to define your data model, and that the prerequisite for that is you need to think about your data model and about your process. I once was as a customer, and they said, we have the requirements endorsed, the requirements from our customer, the stakeholder requirements, they are endorsed, and your tool should extract them. Okay, how can I extract? How can I find them endorsed? Is there something to distinguish them from other requirements? Yes, they are in this module. So, and I looked in the module, extracted the data. That's too much. We need another filter and that filter. And you forgot that module. So if you formalize your process, and you need to do this if you use a tool, you are forced to define, to really look fine granular on your data model. Yeah, that's true. So second thing, I mentioned the requirements have attributes, and you need mapping to map your artifact data on your model data. So here's an example. In this example, we extract requirements both from doors and from Word. And imagine the requirement had an attribute called approved, and it's a Boolean. So requirement is approved or not. And you can now define rules, say, if the requirements comes from doors, and doors has an attribute approval status, and if this attribute equals approved, then make the data transition so that this requirement is considered approved. But for Word, it's a different story. Word requirements don't have an approval status. Every requirement in the Word document, which is not of style strike through, is to be considered approved. So these are really mapping rules. So you can unify really your data. When we look at test cases, I was a project, they had several test cases, and if a test case was failed, so the attribute signaling and test case field was either an X or not okay or an empty value. They had quite a zoo of attributes, all with the same semantics, and we could map those zoo to one attribute in our data model. And yeah, the benefit is you then have this data model, and you then can define the data evaluations and reporting based on that data model, and you don't have to care about data formats in your engineering tools.
And that increases also the quality of the data, because you will find out all the inconsistencies of the various options to express one and the same thing.
That's true. That's true. So but there is one thing that maybe is hard. You need to link your artifacts. I said these projects have really 100,000 artifacts. Who creates the links? That's a tough task, and but we have luck for two reasons. First of all, as I mentioned, several tools provide linking capability to his direct neighbor. So you can import your test cases in your test tool, and you develop a test case and say this test tool, this test case belongs to this or that requirement. So quite a lot of links are already there. Maybe, let's say, between two tools or within one tool. Of course, you can link your requirements to each other. So if software requirements and system requirements are on the same tool, they are linked in the same tool. And so, but you should reuse this information. You need access to this information just to reuse it in your data model. Second thing is you can define formal rules to derive links on attribute similarity. We once had a case, all software files, all C files in a directory called washer belong to the component named washer. And if there is no component that fits the directory rename, then raise an error. So traceability from a software developer's perspective in this case was applied only by putting the file in the right folder. And that you don't even have to create a link for that. And that is really powerful. We're experimenting right now to apply artificial intelligence approaches. So to suggest links, or this requirement is talking about, let's say, timeouts, and you have a software component that is called timeout. Maybe they should be linked. So we're just experimenting with that. It's R&D topic, but it looks promising. Yeah. So, but anyhow, there are quite a lot of links to create, and if you want to build a tool which provides linking, really invest in the link editor. Do it really user experience design. Make it as easy as possible to create links, because it's a tough task and nobody wants to do this. But in the end, you need it to be standard compliant. So yeah, we did quite a lot of workshops at customers and let the customer explain to us his work. And we designed our link editor together with the customers, several customers of several companies, to make it really bulletproof safe. Yeah. So last thing, analyze your data. And there are two kinds of analysis. So in my eyes, the traceability tool needs a means to create an ad hoc analysis. So spontaneous queries. Let's say an engineer wants to figure out what is his work today. Or we once had a case, there was an assessment, and the customer had to prove that he has to that is compliant with Automotive Spice, and the assessor wanted to see a particular report, and the report was not part of the standard repertoire of this customer. So they just created an ad hoc query and created the report really during the assessment. And so you need to make it possible ad hoc queries, depending on context, urgency of cases, customers pushing, assessors pushing. That's a must in my eyes for traceability tool. But on the other hand, there are quite a lot of standard reports that you need to run every day or each week. So create a dashboard which visualizes your standard queries and standardized reports and metrics. And if you have the same ad hoc query that occurs ad hoc each week, then it may become a standard query. Yeah. So provide a dashboard, and there is one interesting, let's say, psychological aspect of this. If you have this dashboard and you're talking, let's say, with the software developers and say your coverage is not so good, it's only 35%, and you show them the report, this is, for some reason, it has a different effect than when you just tell them, I measured your coverage and it looks not good. And they say, we know, but what should we do? But if you give them the task, make this bar green, that's a different story. And they start to like it. It's I don't know if this is kind of gamification or something, but it works out in projects. That's what I've seen.
Yes, I was just to mention gamification too,
Yeah.
because probably we as computer scientists or software programmers, we want to get the number high. And,
Yeah.
it's an incentive to have it grow.
Yeah, absolutely. So and on the other end, you really have success. So I raised it from 35 to 70 instead of it's not complete. It's not complete. Yeah. Then once you have such a metric tool and you say, oh, 35% are not covered, you want to click on this block and see the details. So you need a drill down. If whenever you think about dashboards and you evaluate tools or whatever, you need a drill down to look at the details. This is in my eyes is really a must-have again. And depending on how complex your data are, drill down maybe several steps, let's say overall, then per module, and then the details of one module. But on my understanding, drill down for reporting tool is a must. And last point, yeah.
Maybe I can just wanted to add a point to that. In terms of usability, the drill down must also be fast. You don't want to wait for minutes to retrieve the data from DAWs or from any other tools again, or start up Rhapsody for 90 seconds until you find something. So you might want to cache some of the data. So because if you investigate it, you want to go like duck, 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 and not fetch a coffee to follow the next step.
Yeah, this is absolutely true. Fully agree. And yeah, keep it in mind. I think I have a slide. We can come back to this as well. So, and then there is a hint in the projects where we really, let's say, elaborated a well-designed process and a mature process and a configuration of our tool that can be applied to multiple projects. So the same procedure in each project, the same traceability data model in each project, the same artifacts. In each of these cases, there was a vocabulary expert, I call him, on customer side. So someone who knows the process, but not only the process, also the traceability data model, but also the tools. He knows which tools and he knows the mapping and he knows the reporting. So this is kind of, let's say, a service guy for the project leads, and he creates the reports, and this is really a driver for success. This guy. Yeah, quite a few customers have them, and for some reason, this is the only person that we talk about with at customer size. And one guy just said to me, "Oh, now we already have 60 projects running in our company traced by your tool." Oh, we started. I thought it was 10. So put one in your company into the position of a data expert or vocabulary expert. That's my hint. Okay, now we talked about the what and the how, and now let's talk about the why. So why do we do this? What are the benefits of traceability? Yeah, the Spice, Automotive Spice definition already mentioned impact and coverage analysis. So impact analysis means I have an artifact. So this software test result, what is linked to it? So or I have this model element. What is linked to this model element? That is, to what is it connected? That's the impact analysis. And there was an empirical study undertaken by Patrick Meder from the TU Ilmenau, and he specified a software system, so stakeholder requirements and software requirements and system design. He did not develop the whole system. That was just for the study. And then he created some change requests. And he let, I think, around about 100 people analyze the change requests. So which requirements are to be changed, which system components are affected. And half of them had traceability information. The other half had no traceability information. And it's not a surprise that the guys with traceability information were faster in their analysis, but the error rate was reduced significantly. And that means you really don't waste your money, because if your analysis is wrong, you may give the wrong price to your customer. You don't get your claims. Maybe the effort is way higher than you estimated, and then you're running out of budget, or some changes are rejected because you think they are so expensive. So this is really a thing. With traceability, change analysis is really easier, impact analysis. So this is an excellent example, and it's, let's say, empirically founded. It's not only some guy talking to you on a webinar. Second scenario, coverage metric. I mentioned coverage means figure out what is linked. And we had this coverage metric definition by customer, and it said requirement is considered covered if it's linked to a test. And if all derived artifacts on the left side are also covered. So a stakeholder requirement is covered if all belonging systems requirements have a test case and all belonging software requirements have a test case. In a real world, this definition had like 20 bullet points. I only put 2 on the slide. And of course, every now and then our metric says this stakeholder requirement is not covered because of. And here's a visualization of this because of. So we have this stakeholder requirement 222, and it's not covered, signaled by this red X. And it's not covered because the underlying system requirement is not covered. Because this system architecture element is not covered. And here finally we have the cause. So this software requirement 4.2 has no test case assigned. So this guy is bad and makes this guy not covered, makes this guy not covered, makes this guy not covered. So visualization, and let's say this is a coverage analysis that does not only consider a link, but really a whole trace. So that's coverage analysis of a traceability tool compared to coverage analysis of a linking tool.
And it's not only verifying that the links are there, but you're also deriving. You basically now you have showing that there's no test case, but you could also make a warning or marker when the test case is red. So it's not only about saying there is no link, but you could also put in additional information from all of the attributes across the linking, across the trace chain.
This is absolutely true, but I had no idea how to put this on one single slide.
There's so much to do in traceability, it doesn't fit in one slide.
Yeah. Another example, so impact analysis. On 2 slides before, we saw that impact analysis is to figure out what is linked. But here's let's say we put it on a higher level. So we have here some test cases which are all failing, and we figure out the impact. So what is the impact of this failing test? When we analyze the traceability, that this test, we see that this test is linked to 12 system requirements and 5 stakeholder requirements. And this failing test is linked to 2 system requirements and 9 stakeholder requirements. And so we can, let's say, recommend, first thing is to fix your software to become this test case successful. And maybe this one on this end has a lower prio. And this is really a real project. Had been a change request from a customer to create this report, because he reports to his customer the implementation status based on stakeholder requirements. So if we fix one test, we get 9 icons green on our customer report. That was the message there. And that's really, let's say, impact analysis, a little bit more elaborated than what you read in let's say, pure traceability theory. Then there is this famous suspicious validation. So in traceability means something is suspicious when it has changed. So a requirement that changed is a suspicious artifact, and all links to these change requirements are suspicious links. And experts are, let's say, arguing whether it should be suspicious artifact or suspicious links. Me personally, I don't care. Here's a suspicious link validation from our tool. So we see that this link from this software requirement to this software architecture component is suspicious because the text of the software requirement changed. And now the engineer has to think, is the architectural model still valid, or can I just accept this change? Don't care. So this is suspicious validation, really signal when something has changed. But to overcome this discussion whether it should be suspicious artifact or suspicious links, we introduced a feature that we call snapshot. So we can, once our data model is formalized, we can compare two data models really easy. So we save our data models at different points in time and compare them completely, not only links or not only artifacts. And we can create a report for that. That's really easy. That's every data expert can create such a report from scratch in a few days. And in our tools, it's just built in. And you see here we have added 18 artifacts and deleted 2 links and added a new link and no changes. And if you would, so it's just a screenshot. If you would look on the changed artifacts, you would really see a list of 18 added. Yeah, simple as that. So compare your project status from different points in time. Some tools call this baseline, but as we don't store the original artifacts, only the data that we extracted, we didn't dare to call it baseline. We call it snapshot. Yeah, I already mentioned it. Once your data are structured, that's really a treasure. You can do way more than pure traceability with it. So imagine this is your trace. You can really do analysis, look at things that are not so well. Here's an example. I just copied it from our release notes. So we built a tool from Yakindo Traceability to a tool called RecSuite from our partner Oseno. And Oseno is a requirements management tool. And they have means to analyze your requirements with regarding to speech quality. So it's this requirement is incomplete because there is this integrate, but it says not where should it be integrated. So the body controller shall integrate existing light software components, but into what? So it's an artificial intelligence evaluation, and it says double check this, please. And this evaluation was built in a requirements management tool, but once we have this data, we can send every requirement text extracted from any tool to this tool, get the answer back, and signal it. So if your data are structured, you can analyze them easily. This is really a benefit. So this maybe the slide title is not correct. It's not a traceability benefit. It's a side effect of traceability. Our goal today, so at ETMS, we are figuring out which evaluations can we do more. This is really interesting in automotive driving with 10 millions of artifacts. And once they're structured in a data store, you can learn a lot about yourself and, of course, improve your process. Yeah, then there's this thing that you already mentioned. So this is a visualization of the configuration in our tool. And yeah, this is a point where I wanted to mention that once you have to define your data model, you really have to think about it. So you really see that software requirements can be linked to either software units directly or via software architecture, via detailed design to software unit. We had a customer scenario when we introduced our tools, they had to do it in both cases. So each software requirement was linked to a software unit, and each software requirement was linked to an architecture element, was linked to a detailed design element, was linked to a software unit again. So in the end, each software requirement was linked 2 times to a software unit. And we asked them, why do you do this? And they say, because we cannot do double checks. We have no round trip. We have not the technical means. That was 1.1. And the other point was because our process responsible demanded it. And we said, that's not necessary. With our tool, you can analyze, you can trace each software unit back to the software requirements, either via this path or via that path. And you can then, let's say, annotate the traceability where it matters. Some software requirements have an effect on software architecture. Some software requirements don't have an effect on software architecture. And you now can trace them to where they really have an impact. And you can analyze, you still can do a coverage analysis that say that each software requirement is linked to a software unit. Yeah, simple as that. So you are forced to get an overview. Before we had this view, we did this always on whiteboards. It's not because of the view. So on the whiteboard, the effect was the same. So getting your process to know better. But of course, if it's built in a tool, it helps. And it also convinces assessors and customers. That's the feedback that we get from our customers. Yeah, then there was this motivation on the Automotive Spice definition. Project progress metrics are possible with traceability. It's a little bit complicated. I try to explain it in this slide. So imagine this is part of your traceability model. Stakeholder requirements are linked to system requirements, to architecture, and so on, to software unit. And we want to figure out the status of stakeholder requirement. And we say, if a stakeholder requirement is not linked at all, we consider it as new. And if a stakeholder requirement is linked to a system requirement, we say it's analyzed. If it's completely linked to software unit, we call it implemented, and everything else we call it work in progress. And now we can really create a nice metric. We've seen it a few slides before. So stakeholder requirement status, stakeholder requirement is analyzed and new and work in progress and implemented. And these are the data that we extract into your data warehouse or business intelligence tooling, or maybe a simple database. And the query expert now can create a query easily and group by status, and you can create your dashboards fast. And the query expert don't have to do quite a lot of joins or whatever. So let the traceability tool analyze the traceability, and let the metrics and dashboard tool create the metrics based on that analysis. So really separation of concerns provided by traceability tool. Okay, now I've, how are we in time? So I have 2 bonus slides, conclusion. So when it comes to traceability, and you are forced to do traceability because of standard compliance, don't stop at standard compliance. Go for the benefits. Go for the benefits and for the standard compliance. Standard compliance is mandatory, no discussion, but go for the benefits. And rule of thumb, depending on the number of artifacts in your project. If it's 1,000, then a semi-automated traceability matrix spreadsheet approach may be sufficient. It works, and it works well. I did this myself. I was in a project, big project, enterprise project, 250 use cases, 250 test cases, and test case 23 was a test case for use case 23. So we did traceability by convention, and it works out. But if numbers increase, you need a tool. And to get the benefits, your tool should be highly adjustable. It should fit into your world. You should not make your world fit to the tool. So you look for an adjustable tool or which can add new features easily and fast. And if you're in this position, you really automotive, autonomous driving, these really huge projects, then I can tell you an off-the-shelf tool does not do it. Even our tool. I don't recommend to use our tool for that, but build your own tool and ask someone who did this before. So ask us to help us to build your tool. That's the message.
And we did that. So we built custom tools, basically.
So in this project with this 10,000, even DOS-NG did not scale. We experimented in one project. We tried several graph databases. And yeah, to give you Amazon Neptune really was capable of these numbers. Second thing, so scenario custom tools. So we did this, and we often, yes, of course, we get stakeholder requirements from our customer to build a custom tool, and they're talking a lot of the visualization of the traceability. So this is an extract from the statement of work, and we always say that's not what you want. Yes, we want it. So ask someone who did this before. We know your first change request. So we implemented the prototype, and then we got real data from the customer and fed the prototype with our real data. And this is how it looks. So this is an impact of one artifact in the middle. So these are the links that for that artifact in a real world traceability project, small project, not this 10 million thing. It's an ECU project, so in this 100,000 area. And I've seen it at several customers, several projects, this happens. Here's another slide. So this is real life data, and this graph does not help you. So we are experimenting with a mix of graph and tables. Yeah, that is where we are now researching how to visualize relations as such to make it capable for humans, not only for machines. Okay, 1 minute over time. I'm through with my talk.
So if there are further questions, please ask them in the Q&A or in the chat window. At this moment, Boris, thank you very much for a very great introduction on a very interesting topic. I think it's interesting because or amongst other things, what we didn't mention, it actually also touches basically all the discussions that are now going around on linked data, digital twin, etc. Because we are actually bringing all the engineering data of a software or a cyber physical system together here. And that's super interesting. Maybe can you say 1 or 2 words? Do you see any connections to the keyword or the buzzword linked data here?
You mean the audience or me?
No, you.
Okay.
You,
okay. Yeah. Yeah. Okay. Linked data is that there are 2 terms, or it has in my linked data has 2 meanings. On one hand, it's a standard. How you can create links across tools based on URLs. Mm-hmm. So that is linked data, or yeah, linked enterprise data. So enterprise data with links. And of course, traceability models that are shown on this slide, they are data models with links. So that they are one form of linked data, and that yeah, but there's more of it. So yeah. That's what I mean with structured data model. Exactly. That's my synonym for linked data, because linked data is set.
Okay, for the specific standard, and we're talking about structured data then. Okay. Yeah. So I do not see any further specific questions. If you are interested in a further discussion, then please don't hesitate to contact Boris and or me either through email or on LinkedIn. We would be happy to go into a further discussion, and we will also provide the link to the recording of this webinar. So thank you everybody for attending. Thanks again, Boris, for the great introduction. And I hope maybe we will be scheduling another meeting or another webinar on traceability and dive a little bit more into some of the aspects. We have a lot of things to talk about in traceability, so I think we could do 1 or more deep dives in the future.
Looking forward to that. Thank you guys. For the German guys, schönen Vatertag morgen. So there's a holiday in Germany tomorrow. Yeah, thank you. I enjoyed it. It was fun.
Thank you. Bye-bye.